Okay, so we just learned how to factor something like this, x squared plus bx plus c. I just want to do some more examples. Actually, the first example is going to look a little different. So let's say it's 3x squared plus plus 24x plus 45. First thing you might recognize is this is not of that form, right? In this case, there's a 3 in front of the x squared, and this has nothing in front of the x squared, or you could think of a 1 in front of the x squared. So I don't know how to factor this. I only know how to factor it when there's nothing in front of that x squared. But what you might notice about each term is divisible by 3. We have a common factor. So if you remember common factoring, we can sort of take the 3 out, or divide each term by 3, and if I divide this by 3, I'd have x squared. If I divide this by 3, I'd have 8x, and if I divide this by 3, I'd have 15. And now notice inside the bracket, you do have a trinomial of this form, so you can factor further and factor it into two binomials. The first term is x squared, so we're going to have an x and an x, and now the product must be 15, and the sum must be 8. So what two numbers multiply to 8? Add to 8 and multiply to 15. So numbers that multiply to 15, probably your first thought is 5 and 3, and yes, 5 and 3 add to 8. So plus 5 plus 3. So this is a good example because it points out a good rule, and that rule is always common factor first. So when you're given a question which says factor, always look for common factor first. We're going to learn how to factor ones that do have a number in front, but not necessarily a common number. But the important thing is, even when we learn those, you should always try common factoring first. Here's another one. Before we can factor this kind, let's try expanding this. So notice in the other examples we always had one variable. Sometimes it was x, sometimes it was y. But sometimes I could put another variable, like x squared plus 2y times x minus 3y. So notice that the x's are first and the y's are second. Well, if I expand this, I still know how to expand this. So the x times both things. So x, I don't need the bracket. So x squared, x times minus 3y would be minus 3xy. And then multiply the second term into the second bracket. So that would be plus 2, and then we'll write xy just to keep it the same, and then minus 6y squared. So x squared, two like terms, so minus xy minus 6y squared. Well, that looks pretty similar to a trinomial, except now, or the trinomials we were doing before, except now there's a y squared second and a y in the middle. Well, I could be asked to factor something like this, right? X squared minus x y minus 6y squared, and I'm going to do it the same way. It's going to be two binomials. The first term will have to be x, because x times x is x squared, and then the sum would have to be the middle number. So in this case the sum would be negative 1, so it's just negative and there's no number there. You could think of it as a 1, and the product would be negative 6. So what numbers multiply to give you negative 6 and add to 1? And we can see from the example over there, it's 2, and negative 3. So we're going to have a plus 2 and a negative 3, but then the y, so we need the last terms to multiply to y squared, so y and y, so 2y times minus 3y is negative 6y squared, and then the middle term would have both the x and the y. So let's just look at one where we try to factor a term like that. So let's say we've got these different variables. Z squared plus, let's do minus 3 z y minus 88 z y. Oh, sorry, not z y. This would be y squared. So notice it's essentially of the form of the one we did before. So it's going to factor as two binomials. The first term is going to be z times z is z squared. Now the last term is going to have a y because of that y squared, and then we need to figure out what's the coefficient of the y. So the coefficients must sum to negative 3 and multiply to negative 88. Okay, so negative 88, there's a lot of numbers that add to or multiply to negative 88, but just sort of first thought would be 11 and 8, but one has to be negative. Now looking at the sum is negative, so I'm going to make the bigger one negative. So negative 11 plus 8 is negative 3, so there are my coefficients. And it doesn't matter which order you put them in, so negative 11 plus 8, and I could have done plus 8, negative 1, it doesn't matter. And then you could just check that you get that back, but you do, so we're good, we factored. So now you can factor it if there's more variables, if there's 2 variables, but it has to be in the specific order, right? You have to have something squared and then something else squared, and then the middle term has to have one of each. If it was different than that, it wouldn't work. So let's do another sort of more complicated example. Let's say something like x to the power of 4, so not just squared here, minus, let's not do this, minus 9x squared plus 20. So notice here the powers are higher, but notice they're both higher. So x to the 4 and x squared, so they're both kind of 2 times higher. Well, we can factor this essentially the same way. But now, since it's x to the 4, what has to go first? Well, if this term and this term must multiply to x to the 4, it's got to be x squared. X squared times x squared is x to the 4. And then the middle terms will add to x squared. But then the rest is the same. So the product will be 20, and the sum will be negative 9. So notice the sum is negative and the product is positive, so that means we need 2 negative numbers. So to negative 20, about negative 4, and negative 5, yes, those add to that. So it's just minus 5 and minus 4, and we're good. And actually in the future we're going to learn that you can expand, or you can factor this one even further. But just to check, make sure that we get back the same thing. If we x times x squared is x to the 4, x times minus 4x squared, negative 5 times x squared, negative 5x squared, and negative 5 times negative 4 plus 20. So x to the 4 minus 9x squared, if you add like terms, and plus 20, and we're good, we get back what we started with, so that would be the correct factorization. Okay, so that's a good sort of set of examples. Let's do one more. 2x squared plus, oh no, sorry. That would be essentially the same as the last example. How about one like this? X cubed plus 18x squared plus 81x. So here you might think, oh, different, x cubed, not x squared. But remember, what do you always look for first? Common factors. So in this case, there's a common factor of an x. Each term is divisible by x. Divide x cubed by x, you get x squared. So now in the bracket we have a just regular trinomial. So your sum must be 18 and your product must be 81. So what number is multiply to 81 and add to 18? Well, product of 81, that might make you think 9 times 9. And in fact, 9 times 9 is 81, and 9 plus 9 is 18. So there are numbers, 9 and 9. So x plus 9 and x plus 9. So there we go, we factored it. You might recognize here that these two brackets are the same. And usually if you're multiplying two things that are the same, instead of writing x plus 9, you're going to write x plus 9 all squared. So if you ever get that, if you ever get two brackets the same, usually you're going to write x, whatever, that bracket squared. So in this case, x plus 9 squared.